This is video B12. It's a calculator problem. And so what we're given here is a function. This isn't a rate function. This is just an amount of grass clippings in a bin at a given time t. And the first question is what is the average rate of change? Remember, that means secant slope over this interval. And so what they're asking you to do is just find 2 points. We're looking for a starting point at t equals 0, ending point at t equals 30. And so this is simply y2 minus y1 over t2, or x2 minus x1. So the average rate of change is just a secant slope. And we're finding that the average rate of change is negative. And don't forget the units. This would be pounds per day. Okay, part B. The value of the derivative of a at 15. So they want us to find that. Remember, this is a calculator problem. But what they would look for is the interpretation of what this means. And so just find, I would honestly put the function in as y1 and then find the derivative with alpha window. And we find the derivative at this given time is negative 0.164. Once again, don't forget units, pounds per day. And then the interpretation that they'd look for would be this, or just write it as a full sentence. So the amount of grass clippings in the bin is decreasing. They would look for that at a rate of this pounds per day at t equals 15 days. Okay, part C. Find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings. So this is a two-part problem. Okay, so average amount, you have to remember the average value. So 1 over the difference in the interval right here, so 30 minus 0, times the area under it. Don't forget, this comes from that sloshing glass of water. You guys have a lot to memorize. You can always develop that if you look back. But this is now, once again, just a calculator problem. Okay, and so we find the average value. And then they're asking, when is the amount, this is the amount for this time t, equal to this average value? Okay, and the more decimal places, I just wrote 3 here, you use, the more accurate your answer will be. So what I would do is, to see when this function is equal to that one, you already have this as y1, make this y2, and calculate intersections. And if you've used enough decimal places, you should get that as your answer. And then part D, the linearization. Okay, don't forget what that means. You have a curve, and you're going to, at a point, find the tangent line and use that to approximate values of the curve. And what they say is that it's a better approximation than the function after t is greater than 30. And so you're going to find the linearization and then use it to predict the time. So you'll solve for t at which there are 0.5 pounds of grass. Okay, so a linearization simply comes from, you guys have, like I said earlier, way too much to memorize. Okay, remember, this is just point slope form. Okay, this is y, this is just y. This would be over here, y minus y1 equals m times x minus x1. Okay, and so your m, your slope, is just the derivative at that given time. Okay, your y and x right here are your t value and the a of that t value. Okay, and so this is a calculator problem to find this and this. So we do. And now we have our linearization. And you want to know when will L of t be 0.5. And so just quickly solve. Your problem next time is a no calculator problem. B13N.